we're going to go ahead and get started. Again, we're on Unit 4 now, okay? So we're Unit 4. And we're going to be going over the Pythagorean theorem. Make sure you guys take good notes. Some of you guys that are falling behind, I'm noticing you're also not getting work done that we were doing in class, and that shouldn't be happening, okay? All right.
Should we scribble out 7.2?
We'll do approximate. So let's take a look at the first one, though. Okay. It's not. Right here. This works. Go. A squared plus b squared equals c squared. All right, now one of the things that some of you might have forgotten on the last test was that you gotta substitute the largest side should always be substituted for the c value, and that's typically opposite the 90-degree angle. But here's what it's telling you guys to do. It's figure out if those sides even make a right triangle, okay? Now, to determine if those sides make a triangle at all, I need you guys to remember you add the two shorter sides, and they should add up to be bigger than the biggest side. So everybody needs to have a calculator. So does everybody have a calculator? Yeah. Let's pass it down right here. You guys got a calculator? Okay. All right. 9 plus 15, you guys agree that's 14, right? Now take a look over here. 3 square root of 34.
9 plus 15 equals 14.
Oh, sorry.
I was like, wait a minute.
Yeah, I'll check and make sure I'm on task here. It's not 14, it's 24, right?
Yeah.
Okay, let's make sure we get those corrections done quickly, too. Don't let me move on any further when I do that, okay?
No, it's fine.
All right, now the next number, how do you guys figure out what that number is? 3 square root of 34. What do you got to do, you think? So, type in 34. Okay, do the square root of 34 first. What do you get?
5.83.
Okay, so 5.83. All right, multiply that number times 3. That's how you simplify that.
17.49.
17.49. Okay, approximately. Okay. All right, so 24, is it bigger than 17.49?
Is that a 3?
5, well, did you type in 34, square root of 34? That's 5.83.
No, I did that.
That 3 is outside of the radical, it's just breaking down.
Oh, I couldn't see it small.
At 3, that's outside the radical, you're waiting to multiply 3 times whatever the square root of 34 is. Okay? All right, so 24 is greater than 17.49. Is that true? Yeah. Yes. That means those sides do make a triangle. We don't know if it's a right triangle yet, though.
We just know.
We just know it's a triangle. Now, we did an activity, remember, when we showed that the two shorter sides, if they didn't add up to be bigger than the biggest side, they collapsed on the two. Because if they weren't big enough, they would just fall on top of it and make two lines on top of each other. Okay? All right, so now we're going to check if it's a right triangle. If this is a right triangle, this is where the 90-degree angle should be, opposite the biggest side always. Okay? So that means this number, 3 square root of 34, is going to be substituted for which one of the 3 letters? C. If you make that mistake, everything else will be wrong because C has to be opposite what the biggest angle is. In this case would be 90. Okay? The other two are your legs, so those two don't matter which one you plug in for A or B, okay? So that'll give you 9 squared plus 15 squared equal to, I'm going to put in parentheses, 3 square root of 34 squared. So pay close attention what's going to happen. Now 9 squared, you guys, what is that?
81.
Okay, 15 squared, help me out on that one.
225.
225, everybody agree? Okay. All right, so those numbers, everybody's okay where I'm getting that from so far? Yeah, okay. Now we're going to do 3 square root of 34 squared, so just kind of watch me. I'm going to do this over here on this space provided over here. 3 square root of 34 times 3 square root of 34. That's how you would have typed it on the calculator, but it's kind of weird because square root of 34 times 3 is 17.49, isn't it? So what we're really doing is we're doing 17.49 times 17.49. Everybody understand that?
305.9.
Say it again.
305.9.
305.9. Can everybody double check that? 17.49 times 17.49? Okay. So do you understand 3 square root of 3 times 3, 3 square root of 34 times 3 square root of 34 is really 17.49 times 17.49? Okay, now do you understand where the 17.49 came when I was doing it over here? Yeah? Okay. So 81 plus 225, what do you get from those two? 310? Okay. Is 310 the same as 305.9? No. So put an X there. This is not right triangle. This is not a right triangle. Say it again.
It's 306.
Oh, okay. 81 plus 225 is 306. Okay. Alright, so that's where you guys gotta verify this. Okay. So that's 306. And the other one was 305.9. Now, do you guys agree that, do me a favor, type in square root of 34 again? And whatever decimal you get from that, leave it on the calculator, okay? Okay, now multiply that number by 3. All right, leave that on the screen. Now, I'm going to need that whole value. Give it, what is it,
17.49 28.
All right, let's type that, multiply that exact number by itself again. I wrote it up on the screen.
305.99997.
Okay, so 305.99997. Yeah? 4 nines. Now,
Pretty close.
it's pretty darn close. The only problem in math is it has to be the exact same number on both sides. You can say 305.99997 is about 306, but do you guys understand the other number was exactly 306? Yeah. So that means then this is not a right triangle, even though it's so darn close. It's so close that you want to say it is, but you can't. You can't say it's a right triangle. Because this angle then is almost 90 degrees. It's maybe 89.9999 degrees, maybe. Or maybe it's 91 point, or something almost 91. It's just not exactly 90. And if it's not exactly 90, you can't say there's a right angle there, okay? So, does everybody understand our numbers were so darn close, like we want to say it's 306 equal to 306, you can't say it, okay? So, does everybody understand 17.492855? We didn't use all those numbers originally. We rounded it off to 17.49. Yeah. Had that 2 in the back been a 5 or bigger, then we would have rounded this off to 17.5. But you guys understand when we're rounding off, you don't really want to round off until the very end. Okay. Let's check the other one. First, I want you to check, do those sides even make a triangle that's drawn? Which 2 sides should I add?
22.
Okay, 22 and 14, does everybody agree those are the 2 shorter sides?
Yeah.
Okay. They have to add up to be bigger than the biggest side. 22 and 14, what do you get?
36.
All right, is 36 bigger than 26? Okay, so do you understand how to check if the if the numbers they're just given the numbers, they don't even give you a figure. Do you understand how to check to see if those sides even make a triangle? Yeah? Okay. Now, we're going to check to see if it's a right triangle. Now, does everybody understand 26 is the biggest number out of the 3? So if this is a right triangle, this is where the 90-degree angle would be. So that means, what number should we use for C then? 26 should be where C is. The other 2 are your A and B's. So write 22 squared plus 14 squared equal to 26 squared. And go ahead and simplify that for me. What is 22 squared give you?
44.
40, 484? Can everybody check that? 22 times 22 is 484? Yeah, okay. How about 14 squared? 196?
Yeah, I think so. I was paying attention.
All right, is everybody agree 14 squared is 196? You guys should be checking these on the calculator. Remember, I'll make mistakes. Okay? Make sure you grab a calculator and we're fairly on the top. And then 26 squared, help me out. 676. Can everybody okay that? Yes? 676? Okay. All right, now all you got to do now is 484 plus 196. What do you get? 680? So is 680 the same as 676? No. So that means this one is not a right triangle then. Not a right triangle. Now, do you notice I used the symbol of a figure for the triangle instead of writing the word triangle? You guys are going to start using a lot of symbols to write stuff out, kind of like texting. Okay? Yeah. All right.
I don't even use something. I just say hi.
All right, so are we okay how to check if the sides are a triangle and to check if it even is a right triangle? You guys okay with that? Yeah? Okay. Now, the next part then we're going to learn is proving that triangles are acute using the Pythagorean theorem. Now, if the triangles, if you end up getting c squared and the number that you get from that is less than whatever a squared plus b squared is, then the triangle is considered an acute triangle. But you also got to make sure that you can read it the other way around. So in your notes right here, this is like your cheat sheet. You can also write a squared plus b squared is greater than c squared. These two mean the same thing. Those two mean the same thing. Put that in your notes. And here's how I can kind of relate it to you. Imagine you're taller than somebody, okay? There's 2 ways that you can say that. If you're taller than someone, right? That means the other person is shorter than you. Does that make sense? If you're taller than someone? Well, you can say that 2 different ways. Well, they're shorter than you. If I say they're shorter than you, do you understand that it implies that you're taller than them? So I'm saying the same thing, just 2 different ways. That's what I just did right here. If c squared is less than a squared plus b squared, it's the same as saying a squared plus b squared is bigger than c squared. Do you understand that part? Yeah? Okay. If this happens, that means the triangle is an acute triangle. If it's an acute triangle, that means all of the angles in the triangle are less than 90. So acute means all angles less than 90 degrees. So put that in your notes. Acute means all angles less than 90 degrees. Okay? You're going to use this to determine some problems. Okay? Now let's see if we can determine if these side lengths form an acute triangle, a right triangle, or maybe it's an obtuse triangle. Okay? Now if it's obtuse, then you're going to do this part. C squared is bigger than a squared plus b squared, but remember, I can write that two different ways. Now do you guys notice how it's written if it's an acute? C squared has to be less than the other two added. Or you could say the other two added are bigger than c squared, right? Look at what happens if it's obtuse. C squared has got to be greater than the two added. The other way to say it backwards is a squared plus b squared is less than c squared. Those two are saying the exact same thing. And if that's true, that means it's an obtuse triangle. Does anybody know what the word obtuse means? Bigger than 90. It's got to be bigger than 90, but it can't be more than 180. It has to be bigger than 90, but can't be more than 180. Because do you guys understand that in a triangle, all three of the angles have to add up to 180? If one of them's 180, there's no way it's a triangle because it's just a straight line. Yeah, you can't have one angle in a triangle be 180. Yeah, it could be 179, maybe. Okay, but that'd be a really big triangle. And to draw it, you just need it to be 179 degrees. It's possible the other two angles could be half of an angle, half of a degree, and another half of a degree. That would add up to the 180. Yeah. As long as the three angles in a triangle add up to 180, then you're good. Those do make up a triangle. Okay. Now, does everybody understand what we did to check if the side lengths form a triangle? All right, do me a favor. Can everybody check, do those sides even make a triangle, first of all? All right. What are the two shorter sides that I should add? Okay. And those should be greater than 6.1. So 4.3 and 5.2 give me 9.5. 9.5 is greater than 6.1. That's true, yes? Okay. All right, now let's check. Is it an acute or is it an obtuse triangle? So which side what number am I going to plug in for C? Always the bigger number out of the three. Always the bigger number out of the three, because if you don't have a picture of it, you have to go off. The biggest number has to be substituted for C, okay? The other two, does it matter where they go for A and B? No, okay? So you're going to type in 4.3, you're going to square that, and you're going to add that to 5.2, you're going to square that. Now you're going to leave an empty box right there, okay? You're going to leave an empty box right there. And then you're going to write 6.1 squared. This box is going to be filled in with one of these three symbols, either the equal symbol, either the less than symbol, or the greater than symbol. Okay? All right. What's 4.3 squared? 18.49? Is everybody okay? Because I don't have a calculator. Okay, 18.49 is right?
Yeah.
Yeah, okay. What's 5.2 squared? Bless you. 27.04, everybody check that? Yeah, okay. Now we need 6.1 squared.
37.21.
Everybody check that, 37.21? Yeah, okay. Now let's add 18.49 and 27.04. What do you get?
499.96.
Say it again, 49?
499.
Wait, that sounds weird.
Oh, yeah.
You probably got a me moment, yeah? You multiplied it? It's alright, I affect people that way. It's alright, remember, that's why we write it out to make sure, yeah? So, 18.49 added to 27.04, what do you get? 45.53, that's why we write it out. So does everybody have that same?
Yeah.
Yes, okay, we're good. All right, 45.53, and now fill in the box. Is that equal to 37.21?
No.
No, okay. Is 45.53 less than 37.21? No. Do you agree that it's greater than 37.21? Okay. 45.53 is greater than 37.21. Is that an acute or is that an obtuse? Not obtuse. If it's obtuse, a squared plus b squared should be less than c squared. We have a squared plus b squared is greater than c squared, so that's an acute triangle. Which means there is all the angles in that triangle are less than 90. Does that make sense? So acute angles, so this is an acute triangle. Okay? All right, go ahead and do this one right here. See what type of triangle 3, 4, and 6 make. Is it obtuse, acute, or a right triangle? Okay? Give you a minute. You do number 4 on your own. Do the work on your handout. These are going to be your little cheat sheets. Okay? Then is 3 plus 4 bigger than 6?
Yes.
Okay, if that didn't happen, then you'd stop right there because you can't even make a triangle with those sides. But you can in this case, yes? Now, does everybody understand why I'm leaving an open box right there? Because you're not sure if the equal sign goes there, if it's the less than, or if it's the greater than. You want to make sure that it's a true statement when to figure out if it's acute or obtuse, okay? And reminder again, your notes, make sure you label on the top of your notes, this is Unit 4. Okay? That way some of you that may not be done with Unit 3, don't mix these handouts up. 3 squared, everybody okay? That's 9. Yeah. And 14 squared is 16, yes?
Yes.
All right. 6 squared is 36.
Yeah.
9 plus 16, 25. All right, which symbol is going to go in this box? All right, is my math right so far? Did I make a mistake? Or did I just say something but I wrote something different? Okay. All right. 4 squared is 16. I might have said 14 squared maybe?
Yeah.
Yeah, okay. All right, but everything on my work though looks good? Okay. Now fill in the box with one of the 3 symbols, either the equals, either the less than, or the greater than symbol. Which one of the 3 do you think will make that true? 25 is less than 36. Does that sound right?
Yeah.
Yeah. All right, so 25 is less than 36. Now notice we did a squared plus b squared, right? So which one, when it says a squared plus b squared is less than c squared, which one is that one? see that's obtuse. A squared plus b squared is less than c squared is obtuse. Remember, this is the same as saying c squared is greater than a squared plus b squared. So remember, there's always two ways to say something. If you're taller than somebody, it's the same thing as me referring to the other person. They're shorter than you. You always can relate those things two different ways. Okay? All right. Any questions then on, this is what we just went over. If it's an obtuse triangle, there's one angle in that triangle that's bigger than 90. Okay? If it's an acute triangle, it's less than 90. It could look like it almost looks like a right triangle, but it doesn't mean it is a right triangle. If it is a right triangle, then c squared is equal to a squared plus b squared. The 90-degree angle would be right there. Yeah? Okay. All right, so let's practice this. I want you to determine whether those sides give you a triangle or not. And then I want you to determine if that triangle is an acute right or obtuse triangle. We'll do number one, the first one together, A. All right, so let's do A together. Let's check and see if those sides make a triangle, yes or no. Show your work. All right, 10 plus 12 are the two shorter sides. Everybody agree?
Yeah.
All right, that should be greater than 30. 10 plus 12 is 22. 22 is greater than 30. Is that a triangle?
No.
You understand why it's not? Yeah, the two shorter sides are less than the bigger sides. So that means what's going to happen is those two short sides are going to collapse when they try to touch each other, and they won't make a triangle. Okay? They can't reach. Okay? They have to reach. And they have to reach enough so that it makes some type of an angle. Because if they both are the same length, the two shorter are the same as the bigger, it still doesn't make a triangle. For example, if the two shorter sides gave you 30, 30 is not greater than 30. It has to be greater than. So it could have been 30.1 maybe. That would be okay. Yeah? Okay, so do we have to figure out if it's acute right or obtuse thing? No. If you can't even make the triangle with those sideways, then you can't determine if it's a right, acute, or obtuse thing. So you can't go any further than that, okay? All right, you guys try to do number 2, or B. You guys try to do B. Once you figure out if it's a triangle, if it's a no, then you can't make it right, acute, or obtuse. But if it's yes, you can make a triangle out of it. Now you should be able to figure out if it's acute, obtuse, or a right. And once you're done with B, go ahead and see if you can do C and D. But I'm only giving you guys about 30 more seconds, okay? So when we stop, let's have everybody stop and pause so we can make sure you're understanding this, okay? All right, let's go ahead and have you finish whatever calculations you're on right now, and then just pause then, once you're done with that step you're working on. And let's just make sure everybody's getting this, okay? If somewhere I'm going too fast, then this is the perfect time to slow me down, okay? All right, let's have everybody's eyes up here. Does everybody agree you're going to add the 8 and the 9 and they should be bigger than the 10? 8 and 9 is 17. 17 is it greater than 10? Yeah, that means that does make a triangle, okay? So now you're going to use those sides to figure out if it's a right, acute, or obtuse. And the number out of these three numbers, which one of them is what you're going to plug in for C, because that has to be correct. Okay. So we're going to do a squared plus b squared, and we'll leave a box there because we don't know equal, greater than, or less than. Whatever one fills that in will determine if it's right, acute, or obtuse, okay? All right, so 10 has to go for C, yes?
Yeah.
All right, 8 and 9 can go in whatever one you want, okay? 9 squared, everybody understand that one's 81, yes? Okay. 8 squared, 64, and 100 over here, right?
Yeah.
All right, do me a favor, 81, 64, what do we get?
145.
145, okay. All right, now fill in the box. What should go in there? Equals, less than, or greater than? Greater than. 145 is greater than 100 is a true statement, yeah? So now you got to remember, you did a squared plus b squared is greater than c squared. So if you're not sure, go back. It's acute. A squared plus b squared is greater than c squared. It's acute. Yeah? So this is an acute triangle. Now I'm gonna teach you 3 words, but 2 of them you already know. Okay? The word scalene, you might not know it.
No.
No? Okay. Scalene means all the sides are different. None of them are the same. Okay? What about equilateral?
All the sides are the same.
All the sides are the same. Or equal.
Same.
Yeah? There's only one type of equilateral triangle. If it's equilateral, all the angles have to be 60 and 60. It's also called equiangular. Okay? So if it's equilateral, it's also called equiangular. Okay? Isosceles, do you know that one?
2 of the sides are the same.
Only 2 sides are the same. So make sure you put in your notes, if you don't know those 3 words, scalene, all of them are different on a triangle, okay? Equilateral, all of them are the same, okay? So scalene, all sides are different. Is that readable? All sides are different? Yeah, okay. Equilateral, all sides are the same. And isosceles, 2 sides are the same. Okay. Some of these words are becoming familiar to you guys now. They're not strange words, not a different language. Strange, okay. But it is a language called mathematics, okay, and you're learning how to speak it. Okay? All right, so now, do you understand how to label something as an acute, obtuse, or right triangle? And a triangle can also be scalene, equilateral, or isosceles. It's one of those 3. Now, for example, the first one, does everybody agree the first one we did is not even a triangle? Okay. The second one is a triangle, and it's an acute triangle, right? Are any of the sides the same? Because if 2 of them were the same, then you would say it's an isosceles right triangle, right? If all of them were the same, then you would call it an equilateral triangle. If it's an equilateral triangle, all the sides have to be 60 though, right? So it couldn't be a right triangle, yeah? It'd have to be an acute. Can an acute triangle be equilateral? Yeah, all the sides, all the angles have to be less than 90. And in an equilateral, there's only one. It's 60, 60, and 60. Okay? Are all the sides different on this problem? Yeah, 8, 9, and 10. None of them are the same. They can't even be kind of close. They all have to be exactly the same. So this is an acute, and it's scalene. Okay? All right, you guys try to do C for me, and D, and E. Okay, now if you get stuck on D, just give it an attempt. Yeah. Uh-huh. All right, you guys try to finish D and D and E. Let's see.
Second number.
And then just check 27. So now you get a squared plus b squared is less than c squared. So which one has a squared plus b squared is less than c squared? Q or x? A squared plus b squared is less than c squared, so it's on a 2 triangle. Remember that you can actually, it could have been a squared plus b squared is less than c squared, or it could be c squared is greater than. And the other way is put stars right here, because that's what you're.
I gotta highlight.
I'll pass the highlighters in a second. Correct. Correct. So, not a cube. If a squared plus b squared is less than c squared, right? A squared plus b squared is greater than c squared would be a cube. You got a squared plus b squared is less than c squared, and I'm going to So you know on D, you're going to have to type in what is the square root of 3 to know what that number is. Okay? All right, so just real quick on the last one, 5 plus 7 was 12. 12 is bigger than 9, therefore it is a triangle. And when we simplified it, we got a squared plus b squared was less than c squared. That means it was an obtuse. And it was scalene because none of the sides matched. They have to be exactly the same length, okay? On D, you understand square root of 3 was 1.73 as a decimal approximately, okay? 1.73 and 1.41 were the two shorter sides, so that was square root of 3 and square root of 2. That's why I'm putting them for A and B. Square root of 4 is the bigger of the 3, okay? Now watch here carefully. Square root of 3. Square root of 3. When you square it though, the square root and the second power symbol cancel each other out, and you're just left with 3. Square root of 2 squared, the exponent and the square root symbol cancel each other out. They're opposites of each other. The same way that if you had a 3 and you subtracted a 3, that's canceling itself out, isn't it? If you had a multiplication of 3 and then a division of 3 right after it, do you guys understand those? They don't cancel each other out by giving you 0, they just give you 1, but they're opposites of each other. Yeah? Okay. Well, opposites of something to the second power is the square root. They're opposites of each other. Okay? So square root of 2 squared is just 2. Okay? Square root of 4 squared is just 4. 3 plus 2 is 5. 5 is greater than 4, so a squared plus b squared is greater than c squared, means it's in a cube. Alright? Alright, and E real quick, 6 plus 8 is greater than 10.
14.
14 is greater than 10, so that's a yes. 6 squared plus 8 squared, and we're going to leave an empty box here.
And 10
10 squared, so we already know 10 squared is 100. 6 squared is
36.
36. 8 squared is 64. 64 and 36. 100. And what symbol out of the 3 should we put there? Equals. So when you put equals, that's a
Right.
right triangle. Are all the sides the same? No. And you notice you can't have a right angle and then it be equilateral. Those two don't go together because equilateral, there's only one, 60, 60, and 60. Is it scalene? Yeah. All the sides are different. Okay, not equal, so it's a scalene right triangle. Okay. You guys getting the hang of how to determine scalene, equilateral, and isosceles? Okay, you guys okay with acute and obtuse and right angle? Yep. Okay. Now let's go to. All right, let's go ahead and see if you guys can do numbers 2, and then put your pencils down. Number 2. Number 2. Just number 2. About 30 more seconds. And if you're already looking at number 3, they're giving you angle measurements, not side lengths on number 3, if you're already there, okay? Okay, everybody, number 4, or I'm sorry, number 2, the sides are 4, 4, and 4. 4 plus 4, 8. 8 is greater than 4. That does make a triangle. Do you understand how to check it? All right. A squared plus B squared, and we're going to figure out C squared. 16 plus 16 and 16, 32 and 16. 32 is greater than 16. So A squared plus B squared is greater than C squared is which one? Is it an acute scalene or is it an acute equilateral? It's an acute and it's equilateral. Yeah? If it would have been acute scalene, all the sides would have been different. Yeah. Okay. Isosceles means there would have been only 2 sides that were the same. In this case, all 3 were the same. Yeah? So the correct one then is, for problem number 2, is an acute equilateral. Okay? All right, number 3. Now here's what I want you to keep in mind. If all the sides are different, that also means all the angles are different. Those go together. Okay? So if all the sides are different, all angles are different. And I'm going to have to go up here and different. If all sides are the same, all angles are the same. Those go together, yeah? If all the sides are the same, in a triangle, all the angles have to be the same. So what do you think on isosceles? If only 2 sides are the same, how many angles are the same? 2. It's all right, I don't either. Don't feel bad. All right, so do you guys understand how the sides relate to the angles then? Okay. All right, so what type of triangle has 2 of the 3 angles with measurements of 24 and 105? Could you find the 3rd angle that's missing? Okay, how would you set up something to figure that out? What would you do?
Add the two angles here right now.
Okay, add them up.
This one, since we're not going to do triangle, do minus what I do.
Yeah, in a triangle, what do we know is always true? 180.
Or you can just minus it.
And you're going to just do 24 and 105 and minus that from 180. What's 24 and 105 give you? 29. And exactly what you said, just take away that number from 180, right? And you get 51. Now I just put a letter there, X, because I didn't know a missing value. Yeah? So that variable is because there was a missing angle I didn't know. I could have used any other letter, okay? So the angles are 51, 24, and 105. Are all the angles the same?
No.
So that means it's not equilateral, okay? Are there two angles that are the same? So it's not isosceles. So it's a scalene triangle. And what type of triangle has three angles with measurements 24, 105, and 51? Are any of those are all those angles less than 90? One of them is 105, so that's bigger than 90, so it's not a cube. Are any of them 90 degrees exactly? No, so it's not a right. Is one of them bigger than 90?
Yeah.
Obtuse. Alright, so now, do you guys understand how to check to see if the sides make a triangle? Yeah, okay. And then you're going to do numbers 4. I'll leave that one for you to do on your own. Let's go to number 5 real quick. It says, Edna and Nancy leave a house of a friend at the same time. So everybody, it says Edna walks due east 7 miles. So what we need to do here is, this is kind of like a problem that was on the Unit 2 test. You guys remember Unit 2? Do you guys agree that both Edna and Nancy both left from the same place? Edna went east, so which way would be east? Left. East is this direction, yeah? So she went east how many miles? 7. And then which way did her friend go? She went north, so which direction would that be? Up. How much did she go? Now, do you guys agree that if she goes due east and her friend goes due north, those two sides put together make a right angle? Could you find out how far apart they are from each other? With the Pythagorean theorem. A squared plus b squared equals c squared. You're missing one side length. Yeah? C. That's the C because it's opposite the 90-degree angle. Okay? So go ahead and see how far are they apart from each other. Out of the 3 sides that you know, which one needs to be plugged in for C? X. It's the one we don't know. Everybody agree? So you can leave it as C, or you can plug X there if you want. That means the other 2 can go in for A or B. Okay? I'm going to need some help with 24 squared. What do you get from that?
576.
Does everybody get that same number, 576? Yeah. Can you add that to 49? What do you get? 625? Or are you done right there?
No.
No, everybody understands you still have to do square root. And what do you get from that? 25 exactly? That means they're 25 miles apart from each other. The question is asking you, what is the straight line between Edna and Nancy? And that's just how far apart they were from each other. Now, does everybody understand they both started at the same place? One went north, the other went east. All right. The only thing left, there's one other thing left, and then I'm going to have you guys working together with each other. Okay? Is you're going to graph points and label them. Now, this formula right here, you can use that distance formula, but I'm going to show you a trick, okay? Yeah, you're going to, let's do the first one together, though, okay?
Yeah, it's not. I don't do that.
All right, so everybody, let's do this one together. Let's graph those 4 points, please. And I want you to label each point with a letter. Doesn't matter which letter you chose. 1, 2, and 3. Oh, I said 4. Sorry. Because I'm starting to see stars. I don't know why I'm seeing stars. Maybe I'm going to pass out. 8 children. Because I haven't eaten anything, that's why.
Better eat something.
Almost.
I'm shoot you with that dust off here.
Go ahead and connect the points. Now, before I make you connect them, can you do me a favor? Use the protractors to make the lines nice and straight.
I'm supposed to touch.
No, you're not going to dash them because we're not going to do a dilation. Make the lines nice and straight. Uh-huh. All right, so everybody should have the points plotted by now for number 1. So let's go ahead and put your pencils down after you've connected the points. Please label each point a letter, any letter you want. I'm going to choose A, B, and C. And you can choose A, B, and C on every one of them because they're all different graphs. Okay? All right, does everybody agree -3, 6 should have been right there? Okay. 5, 5 right there. And 3, 2 right there. All right. And I can't use a ruler on this smartboard because then 2 things touching it throws it off. Okay. So I'm just going to do little dots so that helps me try to keep it as straight as possible. All right, so you guys got the figure, it's a triangle?
Yeah.
Okay. Now, you're supposed to figure out the side lengths of that triangle from the graph paper. Now, do you notice that none of the sides are on a vertical or horizontal line? So what that means is you can do 2 things. You can use this formula which says the distance between any 2 points is x1 minus x2 squared plus y1 minus y2 squared, and then you do the square root of all that. Now, that's one way to get the distance between 2 points. Now, if you're writing it down, I'll give you a few seconds to write it down. And this is the distance between any 2 points, x and y, okay?
world.
Alright. I'm going to show you a trick, okay, where you don't have to use that formula the way it's set up right now. I'm going to show you how to use something that you've already been doing. You just did it on the very last problem, too. Huh? What did you guys do on the very last problem? What was it? Diagram theorem. So watch. You're supposed to figure out the side lengths of A to C. You're supposed to figure out the side lengths of A to B. Now, do you notice that I'm writing a line over the two letters?
Yeah.
That represents just a segment. If I put an arrow like this, then I start saying that's a ray because it starts at A, it goes through B, and the line keeps going on forever. If I put two arrows there, that means the line goes in both directions. I'm not doing that. And that's just something that I want you guys to start paying attention to the way I'm writing the lettering. The other thing that you got to notice is I'm using capital letters for points. So whenever we're doing points on X and Y axis, we're going to use capital letters. Okay? All right, so we're going to find out what the length is of AC, AB. There's one that's missing. BC. So we're going to find all three of those side lengths. So now, if you use this distance formula, you guys see, first of all, just writing it takes a lot of space, doesn't it? And you're going to have to do that for all three of the sides. Well, let's try this. If you notice, none of the sides are on a vertical line, and none of them are on a horizontal line. But if I connect to, you notice, I just made a right triangle. If the sides are on a vertical line and a horizontal line, you can just count those square units. Okay, how much does this side measure right here? 1, 2, 3, 4. That side measures 4. How about this side? 6. You guys see that's a right triangle, and when you solve for C, that's the length of A to C. So that's going to be 4 squared plus 6 squared is equal to the letters A to C. Yeah. 4 squared is 6 squared is
36.
16 plus 36 is 50. 52 maybe, right?
52.
Okay. I'm starting to roll off
Does
my
it say
fingers.
AC in the top?
Yeah, AC.
AC squared?
Do you notice AC is the side that makes where the hypotenuse would have been because it's the one that's missing? Okay. Am I done right there? Square root of 52 is how much?
7.2.
So AC measures 7.21 approximately. All right. Can you guys try to figure out from C to B for me? I'll give you a minute to see if you can figure out how to set up, knowing what I just did, okay? When I labeled from C to B, when I labeled from C, I did a horizontal line, and from B, I did a vertical line to make this blue triangle right here. And you understand where I'm getting the 2 and the 3, right? All right, so when I set this up, 2 squared plus 3 squared equals which side? From C to B, okay? Or B to C. Okay. Go ahead and simplify that. 4 plus 9, which is 13.
square.
Square root it, good.
We're gonna get 3.60.
3.60,
BC.
or 3.6 is CB or BC. Okay. All right, and so far we've gotten the side from C to B, the side from A to C. Which side is missing? A to B. Okay. Give you 1 minute. You try to figure out A to B now. Got it? Getting the hang of that. Notice there is no side that's on a horizontal and a vertical line, so you got to make that a triangle to make it easier.
So BC is 3.6.
Mm-hmm. Approximately, so you've got to make sure you use the wave marks because we're not doing exactly. Okay. Now on this one right here, does everybody see that when you extend it, the triangle is really small? You still can count the sides though. One of the sides is just 1 unit, and it's the A or B side. And what's the other one then? 8 units. Okay. And that all should equal what 2 letters?
A, B.
A to B. Don't forget that that's squared, okay? All right. So that's just going to be 1 plus 64, right? And that's going to give you a 65. Square root of 65 is how much?
8.06.
Can everybody double check that?
Yeah.
Yes? All right. So here are my side lengths, 8.06 for A to B, 3.6 for C to B, and 7.21 for A to C. Did it make sense how I drew these other right triangles in the pictures to help me just count sides? They're already there. Yeah? Okay. You're not gonna have to do that for all of them. I just needed to make sure I had one of them in there. There might be one more in these, okay? So can anybody do me a favor? Are there any questions on the first one? No? All right, did you guys write down the coordinates for the second, third, and the fourth one? All right. On number 2, that's 3292 and 37. Okay. Okay. On over here, with the one I labeled 3, that's -2, 4. The other one is -5, -4. And then -2, -4 for that one, number 3. For number 4, it's 3, 6, 3, 1, and 7, 1. Okay. I'm going to have to erase this here because I got to show you the back side. Flip it over. Okay, on the back side, take a look at the coordinates for the 4 that you're going to do. There's only one that looks kind of weird, and that's this one down here. That's -8, -3. I think everybody else can read all the other coordinates on the back side of that page. Yeah. All right, so you're gonna finish those four, and then there's one sheet that's a Pythagorean theorem sheet that you guys are gonna do, and once you're done with those, that's it for today.
You can take this home too, right?
Yeah, if you don't finish it in class. Some of you guys are gonna be done sooner than others. Yeah.
Oh, wait a minute. Isn't this like part of unit 2?
Yeah, pretty kind of. Part of unit 2 is,
Because we don't, you said skip 3.
oh, 3, I actually have the correct coordinates of that one. On the handout I just gave you guys, on number 3, there's a side that's missing, and it's 17. Can everybody check it for number 3?
Wait, what?
For number 3 on the handout that I just gave you, it's 17. It didn't come out good. So that handout right there should be fairly easy. We just did all that right now. Yeah, okay. So go ahead and finish wrapping those rest of those then. And then that's all we got for today, okay?
Can we get the top? Or I didn't get to finish them.
Okay. This is the back page. You didn't get the other page?
I didn't,
That's the back page. Did you get the other page?
I didn't finish writing down the.
Okay, somebody should be able to give them to you. Because they're upside down now.
I'll stare.
Yes.
Oh,
Okay.
This one.
listen.
Oh.